Hello, I'm Dee, and I've got a group on Facebook called Very Basic Maths UK. Today I just wanted to talk about times tables. There's lots of different ways to learn times tables. Some people, it works for them if they say them out loud and repeat them, and that helps them. That didn't work for me. Sometimes it can help if you write them out and look over them again and then write them out again. There are lots of different ways. It can help if you can find patterns as well in maths. I'm going to talk about some slightly different things today, and the first thing is the 2 times table. Now most people don't have difficulty with the 2 times table, but sometimes if you're somebody that struggles with maths, just hearing somebody say times tables or multiply by or times can actually trigger a bit of an anxious response, and if it does, then that's going to make it more difficult for you to engage with the rest of what you're doing. So another way to look at the 2 times table is to say double. So instead of saying what's 2 times 4, which is 8, you could say double 8. Sometimes people find that easier just because it doesn't sound like a classroom, it sounds like real life. So that's a little trick you can use. Now, beyond that, you could then look at the 4 times table, because okay, see that. 2 times 2 is 4. So if we're looking at the 4 times table, we could say double and double again. So if you wanted to know what 4 times 6 was, you'd say 6, double, 12, double again, 24. That's quite a nice way to deal with your 4 times table. Practice that a few times and it works for you. Then you could use that for your 8 times table, because 4 times 2, 4 doubled, is 8. So if you wanted to do 8 times 6, you could say 6 doubled, 12, doubled again, 24, so that's your 4 times, doubled again. Now, can you double 24 in your head? You might be able to. It's 48. So 8 times 6 is 48. It's just another little trick you might want to use. What other tables can we talk about? Right, the 5 times table. Most people are quite good with the 5 times table, especially if they're saying 5, 10, 15, 20, 25, 30, 35, 40. Whereas if you say 7 times 5, they might not know that straight away, but they could count up on their fingers, and that's great. The thing is with your 5 times table is just remember that everything ends in a 0 or a 5. So if you think it's 37, you've gone wrong. It can't be. It can't be your 5 times table if it ends in a 7. The one I want to talk to you most about today is the 9 times table, because it's my favourite table. It's got a lot of tricks with it. So. I'm not actually sure why the 9 times table is magic, but it is magic, and it must be because we use base 10, which means that when we get to 10, we suddenly have another column. So we'd have our units column, and then we get to 10 and it suddenly jumps to 1, 0. We have a tens column, we have a hundreds column. That means we're working in base 10. And I think that's why it works, but I can't explain it any more than that. If you needed to know your 9 times table quickly, one thing you can do, and I've had learners come up to the board to do this, and it works quite well. So I'll see if I can do this like this, okay? So what you're going to do is write 0 to 9 just down in a column. So that's easy enough to do, okay? Then what we're going to do is do the same, but start at the bottom and work up, making sure that the numbers line up together. So, can you see how I've lined up the 0 with the 1? And I'm going to carry on like that up. There we go. That's actually your 9 times table. So you could write that really quickly on a piece of paper in an exam if you needed to do that for your 9 times table. and then you just count down. So if you wanted to know 5 nines, count 1, 2, 3, 4, 5 nines are 45. So that's a nice little thing to do. Now some of you might know the trick with your fingers as well. So let's just see if we can do this. Now you might find it easier to hold your hands down on a table to do this, or you might find it easier to do in the air, okay? I'll need to do it in the air because you won't be able to see it if I have my hands down. So what we're going to do is, I've just said 5 times 9, so if we did the same. So if I hold my hands like this so you can see, so because we want 5 times, we're going to go 1, 2, 3, 4, 5. So that finger, we need to somehow hold it down or know that it's separate. Everything in front of that finger is our tens. 10, 20, 30, 40. And everything left on this hand is our units. 1, 2, 3, 4, 5. So 5 times 9 is 45. I'm going to do that again for you because that's perhaps a bit quick. So we want to know 5 times 9. This only works if you're blessed with 10 digits. I did have a learner who had a finger missing. It didn't work for him. That's serious. So we're going to do 5 times 9. So you start over here. 1, 2, 3, 4, 5. Put your finger down. Then you've got 10, 20, 30, 40. 1, 2, 3, 4, 5. 45. Okay? So we'll do that again. Let's do 7 times 9. Okay? So again, there's your hand. Obviously you wouldn't need to twist. You can do it this way, but it's the wrong way around if I do it that way. So we do it there. 1, 2, 3, 4, 5, 6, 7. So the 7th finger is the one that separates the tens from the units. So now we've got 10, 20, 30, 40, 50, 60, 1, 2, 3, 63. Okay, so 7 nines are 63. Let's do another one. Let's do 2 nines. Okay, 1, 2, put that down. There's just 10, and then 1, 2, 3, 4, 5, 6, 7, 8, 18. I hope that makes sense. It's quite. Some people really like that method, and others just think it's awkward. So it's about you as an individual. So that's also your 9 times table. Something else I'm going to show you. If we look at what we had there, the 9 times table, what happens if we add the digits? We could do. Okay, so the first one, I'm adding the digits 0 and 9. We get 9. Let's try the next one. 18, 1 and 8 add up to 9. Sorry, you can hear my washing machine in the background there. 27, 2 and 7 add up to 9. We could go all the way down there. Every single one of these numbers adds up to 9. So, I might that be useful. Oh, that is interesting. That's quite a large number. That number is what is it? What is that number? 213,876. Now, I'm not sure why I might want to know this, but if I wanted to know if that number was divisible by 9 exactly, I could find out by adding the digits. So, if I did, I've got to do this in my head because I haven't pre-prepared this. 2 and 1 is 3, add 3 is 6, add 8 is 14, I hope, add 7 is 21, add 6 is 27. Okay, and then we take the digits in the answer, and you can just do this as many times as you need to. So 2 and 7 equals 9. I know that number, 9 goes into that number exactly. I'll prove that to you now, she says. Right, so we're going to do division. 9 into 2 doesn't go because 2 is smaller. So we put a 0 there if we want to, and we carry the 2 onto the next number. 9 into 21, how many times does that go? 2 9s are 18, so it goes twice, and we've got 3 left over, so we put the 3 there. 9 into 33 goes 3 times, that's 27, there's 6 left over. 9 into 68 is going to go 6 times, 6 9s are 54, I hope. So that would leave, no, that's not right, is it? That's not right. Right, you see, I can make mistakes too. It's fine to make mistakes, because that would leave us with 14. Now, if we've got 14 left over, there's another 9 in there, so I've made a mistake there. I know it will be 7, because 7 9s is 63. I did that just now with my fingers. There we go. So 63, what does that leave us? That leaves us with 5, I hope. As I said, I'm doing this. 5. 9 into 57, now that's where the 54 comes into, so that's 6, and it leaves us with 3, and thankfully 9 into 36 is 4. So that proves to you, although I made a couple of mistakes, that 9 does go into that number exactly. So that's just a little thing to know about the 9 times table. I'm pretty certain there's something else as well, and I can't remember what it is now. You might know some things yourself about the 9 times table. One other table I will just do, I don't want to do too many, but this sort of relates to the 9 times table in a way, and this is the 3 times table. So let's think what the 3 times table is. We've got 3, 6, 9. What comes after that? 12, 15, 18, 21, 24, 27 and 30. That's up to 10 times, okay? You could carry on. So we've got 3, 6, 9. Doesn't look like there's much of a pattern there, but let's see. What do we do? If we do 1 add 2, that comes to 3. 1 add 5, if we're looking at 15, comes to 6. 1 add 8 comes to 9. 2 add 1, guess what? 3. Can you see a pattern emerging? 3, 6, 9, 3, 6, 9, 3. I think we can see what the next one's going to be. 2 add 4 equals 6. 2 add 7 equals 9. 3 add 0 equals 3. And in the same way that the 9 times table, if you have a really long number and you add up all the digits, and if you've got lots of digits in the answer, you add them up, you keep adding up till you get down to a single digit, you'll get down to a 9. With the 3 times table, we could do exactly the same, but we would end up with a 3, a 6 or a 9. Notice that we've got 9 here in the 3 times table as well. But that's because 9 is a multiple of 3. In other words, 3 goes exactly into 9. So anything that's in the 9 times table will also be in the 3 times table. It doesn't work the other way around. Anything in the 3 times table isn't going to be in the 9 times table unless it's got them, if it adds up to the 9. The ones that add up to 3 and 6 won't be the 9 times table. I hope that's not too confusing. I think that's enough, and I think I'll leave it there. Thanks very much.